All right, we're going to talk a little bit about code. The last presentation was up here in the stratosphere. We're going to go down in the weeds real low because it's important. Hopefully you get some information you can use in your data centers. This whole thing started about 2006. We realized as an industry we were having some issues. We had to get some code changes in place. I worked with Richard Schlosser from TiePoint, from Steve McClure at Group Schneider, David Boston from the Uptime Institute at that time, to get some fixes into the codes. We're going to be discussing what those fixes were and what your obligations are if you're going to use those fixes. So we're going to talk a little bit about the history of data centers, the core issue with NFPA 70. We're going to flash forward a little bit to the current codes. We're going to talk about critical operations data center systems, okay, which is a new designation under the code. And then your strategy for dealing with AHJs, those people who really can pull a rug out from underneath you or they could patch on the back. So the history of data center codes really started back in 1959 or so. As with any code presentation or any code book, you always have to start with definitions. I want to call your attention to two things. First of all is the standard definition. A standard is a documented practice or recommendation that has been developed through a formal consensus process and approved by the American National Standards Institute. We have a couple of standards we have to follow. Most importantly, the code piece of it, which is standards that have been adopted by governmental entities which have the force of law, and that's what we really worry about. So as I said, back in 1959, a huge fire at the Pentagon. And nothing gets government attention better than something that goes wrong at the Pentagon, as you well know. At that time, about $7 million worth of damage, which in today's dollars was about $53 million of damages. Government said, how can this possibly happen? We have to do something about it. So they went to the National Fire Protection Association and said, we need some codes around this stuff. We need some standards around this stuff so people can design to it and we can use these within the government. These slowly evolved over time until we got to 1968, where NFPA 70, the National Electrical Code, first addresses the data processing systems. Now, I have to note here, standards are standards, but you're only legally obligated to obey the codes. So we're going to focus on the difference between those two. If you haven't seen it, this is a copy of the National Electrical Code 2011. How many people have had problems sleeping in a hotel at night? All right, grab yourself a code book, read a couple of chapters, you'll be out like a light, okay? Very important book. It's very prescriptive in nature. This is what you have to do. But basically, we have two standards that we follow, NFPA 75, NFPA 76. One is for the protection of technology equipment, the other is for the protection of telecommunications facilities, and then the National Electrical Code. Here's one of the areas where you sometimes run into problems with AHJs. If you say that you're designing to a particular standard, in this particular case, most of it is NFPA 75, they assume it's a code. You have to differentiate a little bit. We'll talk about how you work your way through that. The core issue with NFPA 75 is the EPO, the emergency power off. How many people in here can tell me how many times EPO actually occurs in the code book? It never discusses an EPO. It's called a disconnecting means. So EPO is a term that we've applied as an industry to it, but within the codes itself, it's called a disconnecting means, and there's some implications around that which we'll discuss very shortly. But an EPO, as the Uptime Institute frequently points out, is a heart attack waiting to happen. Okay, this is a couple of pictures that David Boston gave me from the Uptime Institute originally. Here's a situation where we have an EPO switch right next to the fire button, and the post-it says, do not touch. Another case where the EPO switch is right behind a copier, so if it's lifted up and it hits that, boom, it's gone. Typical installations for fairly unsophisticated, immature environments. When that happens, it's gone. When I worked for a major financial institution, we actually did a case study of where our failures came from. Okay? So in this particular case, the case study pointed out that 26.3% of human errors were directly related to the EPO switch, that disconnecting means. And these are the examples. Typical one was paper delivery person presses EPO button to hold the overhead doors open, dropping a data center. In other words, the doors weren't staying open long enough. There was a door switch and an EPO switch for the data center because you have to have it near the means of egress. So he hit the EPO switch, the door stayed up, data center went down. Typical instances where the EPO switch is a single point of failure within the data center. So why do we have EPO circuits? The two rationales typically given are that the firemen need to rapidly disconnect power, okay, and it allows the HVAC systems to be shut down so you're not feeding the fire with more air. However, there are no commonly reported incidences where the EPO actually did its job. There may be one or two isolated, they're not published across the industry. So we have this question in the back of our head. And what's happened is people are more at risk when a data center is easily shut down. And we're going to see cases of this as we go forward. Where do these risks come from? Air traffic control. Can you imagine having a data center where you have the air traffic controllers tied in and somebody hits an EPO switch? Talk about delays on the ground. Never mind the poor guys upstairs. This is actually what initiated our ability to get some changes into the code, because a lot of the authorities having jurisdiction are fire marshals, and they're directly tied into 911 call centers. So when we started asking questions is, are you requiring an EPO circuit, a disconnecting means, in your 911 call center? Stop and think about it. And that sort of switched the whole argument around, because people can get killed with data center failures these days, especially on the medical side. All right, this one I have to read to you because it's really important. This is what the code actually says, all right? A means shall be provided to disconnect power to electronic equipment. That's straight out of the code book. A similar means shall be provided to disconnect power to HVAC and close dampers. So in other words, you shut the airflow down. The control for these shall be grouped, identified, and accessible. All right, the use of a single means to disconnect both HVAC and power shall be permitted, but it's not required. How many of you think that an EPO button is a requirement for a data center? Most people do, most designers do, but that's not the case. EPO in this particular case, when you use a button, is all or nothing approach, and there's no consideration to the impact on the shutdown. All right? There's an assumption that you have to have an EPO switch and that everything has to be tied into it. Not true. Do you have to have an EPO switch at all, or a disconnecting means switch at all? Only if you require that the boxes, the electrical boxes underneath your raised floor, have the ability to be moved around, and you want to use non-plenum cable. So if you eliminate the raised floor and you feed from the top, you really don't need an EPO switch at all. So we are beginning to see in certain applications people move away from raised floor environments, and this is one of the primary reasons. Flash forward 2011. There's been a fundamental change in philosophy. The past codes were all about fire protection, fire detection, and fire suppression. It's all about the fire. The current codes are thinking in terms of what the impact is of that disconnecting means to a data center operation and to society as a whole. It's interesting that they put in language that says you can designate a critical operations data systems or parts of data centers, and that these can be granted by governmental authorities for facility engineering documentation establishing the necessity of critical power operations. In other words, we've seen a shift. If you can business justify getting rid of an EPO circuit because of the criticality of your data center, you can do it. provided you have the cooperation of the AHG in getting the approval, which we'll talk about. Two big EPO changes. The first one is zones. Okay, you have the ability now, instead of having an all or nothing, to be able to zone your data center. But there's a couple of requirements there. You have to be able to section it off, both on the HVAC side or with walls or designated areas. Okay? And the EPO switch has to affect that area. Okay? There are certain exemptions from EPOs, which we talked about. These exemptions revolve around the CODs, or the codes. Okay? Critical Operations Data Systems. Number one, you have to have approved procedures for removing power and air movement in a room or zone. Two, you have to have qualified personnel that are continuously available. In other words, you can't have a dark site. People have to be on site and they have to be qualified personnel. What are qualified personnel? Doesn't really say. Basically, the authority having jurisdiction are going to be able to say, yes, you have qualified personnel, you're done. He's going to look at the training program, he's going to look at your selection, he's going to look at licenses. It's very difficult to have a security guy be a qualified personnel, okay? You have to have smoke sensing, you have to have an approved fire suppression suitable for the application, typically dry pipe sprinkler systems, okay? And you have to meet certain stricter wiring requirements, and you can read that as plenum type cable where you use that. Oh, and one other change. We have a whole new article in the code book now related to critical operations power systems, and it talks about if you have one of these sites, what's required to do that. You have to have commissioning, you have to have operations, you have to have monitoring, you have to have control and maintenance, and it all has to be documented. But the important thing is the shift has been away from fire as a requirement into the criticality of the data centers. All right, let's talk about cost and benefits. So what is a critical operations data system? An IT system that requires continuous operation for public safety, read 9/11, emergency management, read FEMA, national security, read Pentagon, TSA, or business continuity. So it allows major enterprise data centers now to be classified as critical operations data systems, all right, and you can begin to get special consideration by the AHJs. Now, if you're going to be a CODS, there are certain things that are going to be required of you. First of all, documentation. You have to talk in terms of risk assessment, and that's not only from outside risks, it's also from the risk of the people inside the data center. Physical security has to be documented. You have to have a testing and maintenance program, and this is very important. Approved, conducted, or witnessed by the AHJ with formal PM program, written records, and testing under load. You can't do no load tests, you have to test. You have to have a commissioning plan and results are posted, and you have to have an emergency operations plan. So that's the first piece of it, the documentation piece of it is how you're going to manage your data center physical governance. The second piece is there are special power requirements required for these things. Two sources of power, surge suppression, generators with time starts, which means when there's a hit on the utility side, it's a timed start, it'll wait 2, 3, 4 minutes before it'll start up. Dual fuel supplies if you have natural gas generators. On-site fuel requirements are stated in the code. The fuel pumps have to be on the critical power systems. You have to have a means for attaching a generator so you can do maintenance on the generators that are on site. In other words, you have to have ability to roll up a generator, plug it in, and be able to operate off that generator, have that be your standby generator while you do it. Think tier 3, right? Extra ground fault provisions for downstream tested availability, selectivity, and the electrical system has to be coordinated all the way down the line. So they're going to want to see a coordination plan. You have to separate and label the electrical system for the CODS. Can't be a common system with the rest of the building. So if you're in a leased building or a co-location, and your area is designated CODS, It has to have a dedicated electrical system. And here's an important one. If you're in a 100-year floodplain, all of your electrical installation has to conform to the wet code requirements. I would say if you're in a 500-year floodplain these days, you probably should meet that, and I'll let Hurricane Sandy speak for me on that one. So cost and benefits. Higher levels of documentation, continuous staffing. The AHG has to be involved with your operations, the oversight. There are capital costs to meet the code requirements, and there's operational segmentation within the data center. Okay, the benefits, no EPO, better reliability. You can get certified to certain other government agencies, think SEC, okay, banking requirements. You have priority consideration in emergencies in your particular area. In other words, if you need to get a fuel truck through there, the local authority is going to allow you to have get on the priority list just with hospitals will come first, public safety comes second, but you'll go third on the list, okay? And you have compliance with other regulatory bodies, again, the SEC type thing. So there are costs and benefits attached to this. All right, now, what's your strategy for compliance? Number one, if you're going to have an EPO, make it safer, okay? Separate the functions, use a switch. Make the activation a positive intentional action as opposed to a bump and run. Cover it and have an alarm. Now we'll give you some examples of this. Separate the functions. Remember, the code says that you don't have to have an all-in-one. You can actually separate the functions. You can have a disconnecting means for the electrical, you can have a disconnecting means for your PDUs, you can have a disconnecting means for your HVAC. All right. Our Tier 4 data centers, can they actually statistically deliver 100% availability? Yes, for short periods of time, but over a long time they can't, because there typically are two single points of failure. One is the EPO, and the other is the ground fault systems. So this begins to address how you attack that particular single point of failure. Switch. Remember, the code says a button shall be permissible, it's not required. So use a rotary switch, preferably one that requires a reset procedure. I mean, the worst thing that can happen in a data center is you have an EPO event, trust me on this one, and you don't know which EPO switch set it off. You go through root cause analysis, you're trying to find out what happened. Was it a circuit problem? Was it a procedural problem? Was it a personnel problem? Well, if you have a formal reset process, then you know it's isolated to there and you can backtrack and you can find out what's going on. Avoid pop-out switches behind break glass covers, as we saw in the original pictures. Switch. Use rotary switches. Cover it. All right? There's nothing in the code that says the disconnecting means the EPO switch has to be easy to use. Okay? It doesn't have to be exposed. All right? It doesn't have to be visible. Only the location of where it's at has to be visible. You could put a big sign up here that says disconnecting means arrow with a cover panel. And then post the location and the activation pieces in all the languages within your data center. I mean, the worst thing that can happen is if you're in Chicago and your cleaning staff is Polish extraction, you need to have the information in Polish on this so that even the cleaners understand what you're doing. Alarm it. You want to know when that EPO is beginning to be activated. Typically, we suggest that you have a cover. There's a sound that goes off when you lift the cover. There's a flashing light or strobe, and make it different, by the way, than the fire system. Monitor it. Use your DCIM program to monitor your EPO circuits and monitor those covers. So if they begin to be activated, there's also a parallel alarm that goes off in your knock. And it should be only reset by an authorized user. Couple of examples. These are from Richard Schlosser, Type 1 Engineering. This is an acceptable installation under the code, and I would suggest a recommended one. All right, it says disconnecting means, it's got a rotary switch, it's got a horn and a light and a cover, and it's embedded into the wall. It's a good solution. Another solution, using a standard NEMA panel with a cover to it. It says disconnecting means, all right, it's labeled in conformance with the code. Doesn't say EPO, it says disconnecting means. It's identified. It has a button that triggers the alarm when the panel cover is open. It has a horn alarm, and this is tied into a lighting system, but there's your rotary switch. Right, I would suggest, because the EPO is so critical to you, work backwards. If it's a single point of failure and you have to manage the risk for that, ask yourself, how am I going to manage that risk? All right, it can spoil your availability from tier 1 to tier 4. It can be sabotage, okay? It stops the data centers with one action. I strongly suggest that you design the system with a test feature. So you can put it into test mode, test the whole thing out, make sure it works, or if you have to have an add-on, in other words, you're extending the area of coverage, you can put it into test or defeat it, so you can tie in the new circuits, put it in test position, test the new circuits before you put it back online. Very common fixes. Strategy number 2, zone your data center. Here's a key. Not all jurisdictions follow the same code, all right? Codes are issued every 3 years. We're currently operating under the 2011 code. The 2014 is due out shortly. I'm licensed in the state of Connecticut. The state of Connecticut still operates under the 2008 codes. They take a long time to adopt the codes. So you have to make sure which code version you're under. But you make sure it's followed. You specifically refer to this article, 645.10, paragraph 3 in your design documents, and NFPA article 75, 10.4.8 is your basis for design. And then you begin to factor in those requirements to set up the zones. The walls, as we discussed, the approved containment areas so that the smoke can't go from one area to another, separate EPO circuits for each area, clearly identified, again, not necessarily accessible, but identified, all right? And then document the instructions on how the fire alarm people and your own people are going to use and respond to those zones. And then you review it with the AHJ prior to building it. You want to make sure they're fully up to date on what you're trying to do and what your basis of design is. Strategy number 3, qualify for a CODS. Again, make sure that which version of NFPA 70 is in your locale. Refer to NFPA 70 645.2 definitions, and then provide justification based on your impact to public safety, emergency management, national security, and most importantly, business continuity. So if you're a very critical data center and you have most of these features already, you can easily justify this and take that step. Here's the important point. Obtain classification documentation from the AHA based on your facility engineering necessitating the classification before you start. Don't try to design it and build it and then go get your occupancy permit. Sit down and explain what you're trying to do. Now, dealing with the AHJs. These are the people that can go, yes, you live, no, you die, okay? You get an occupancy permit. A lot of cases, it triggers payments if you're financing things to get that occupancy paid. It can be a bad headache if this guy or this lady is not on your side. So a couple of things. Be polite and deferential. They're trying to do their job. Keep them informed early and often. If you're going into an area, the argument I like to make with the AHJs is when we're going in, we're building a big data center, is we go to the local municipal authorities and we say, we're building a data center in your area. This is a huge, big tax increase for your grand list. There's going to be a lot of value in the computers, a lot of value there. We need to work with your building department. This is what we're intending to do. Cool. Glad to have you. Provide relevant and factual information, okay? No opinions, no arguments. This is what we're going to do, this is why we're going to do it, and this is what we're basing our decisions on. Respond to questions directly with facts, okay? Don't ask for design advice. Well, how do you expect us to design this? He's not going to tell you how to design it. She's not going to tell you how to design it. Ask for approval. Based on this in the code book, based on the local codes as adopted, based on the standards that we're following in FPA 70, 75, 76, and based on the local code with this paragraph, this is what we're trying to do. Okay, then you'll come in and you walk them through. Remember, if you're going for a CODS designation, the AHG actually has to be part of your testing program. He or she has to look at what you're trying to do and how you're trying to do it and be included in either witnessing or actually performing the testing. So you rope them in. The suggestion I make is have a pizza party in your data center. Invite all the fire guys out. All right, walk them through, show them where your battery plant is, show them where your water treatment stuff is, show them where the hazards are, show them your procedures if a fire comes, what you're expected to do. Bring them into the process, win them over. If you're trying to butt heads, and there are certain jurisdictions in the United States which are very tough jurisdictions. San Francisco is one of them, all right? Phoenix is one, Chicago is one. But if you're dealing with AHJ on a positive basis and you're explaining what you're trying to do, it goes much smoother. So those positive relationships are really important and do it proactively. So, how do you prevent a heart attack in the data center? Use only EPO circuits if you have to. Separate the EPO switches to prevent the big one, to take the whole data center down. Design the end-use devices to avoid human error issues. We talked about the covers, we talked about the switches. Design the system to be safe for monitoring and modifications, and then document, document, and document. All right, the more documentation you have on the EPO circuit, the longer your data center is going to live. Credits, Schlosser, Peter Gross from Bloom Energy, Steve McClure, Group Schneider, Tom Roberts from AFCOM, Mike Holt, ECNM, Granger Supply Uptime Institute. And if you want the original white paper, which triggered this, is EPO Dudley Spoff, and that's by myself, David Boston, Rick Schlosser, and Steve McClure. So I'd encourage you to go online and reference that. All right? I hope this has been useful to you. Any questions? It's been a great conference. Appreciate you showing up. Oh, we have a question? I can't see in the spotlight, so where are you? Oh, got it.
Not really a question so much as a comment. I'd have to 100% agree with you on involving the AHJ. When we developed the first large data center in the Quincy area in eastern Washington, the AHJs were used to dealing with houses and barns and agricultural facilities. So we actually brought them over to the Seattle area and toured them through data centers so they could get an understanding of what we were dealing with, the quantities of fuel, the lead acid batteries, the electrical systems, the EPOs, and really, really, really went out of our way to engage them, and it was very successful. So everybody's not going to have that opportunity to tour the AHJ around, but the more you can engage with them up front, treat them like professionals, and engage them, the better you're going to be.
I was going to say, courtesy gets you a long way. Anybody else? There's one over here. No? All right, thank you very much. Have a safe home, and as we say after the last presentation, go Bruins. All right?